Self-supervised learning, or SSL in short, has taken the center stage in modern state-of-the-art machine learning systems. Large language models are pre-trained in a self-supervised way using a language model objective. These foundation or visual models are trained with different flavors of contrastive learning. LLMs have achieved outstanding performance across all conventional natural language processing tasks such as sentiment analysis, translation, summarization, question answering, or dialogue. For image representation, recent models achieve accuracies above 87% on ImageNet, evidencing that the gap with the absolute supervised state of the art is drastically shrinking. Besides excellent performance on standard benchmarks, these models have shown strong out of distribution generalization, opening new research avenues. SSL has been successfully applied to narrow domains, unlocking considerable model improvements such as medical image analysis, learning phenotypic representation of cells, and canopy height estimation for forest growth monitoring. SSL is unsupervised because it does not require human annotations for training the model. Because of that, SSL enables scaling both the model and data without constraints regarding data annotation. But many previous attempts at scaling models and training data size have yielded unsatisfactory results. LLMs trained on large pools of ill-curated text corpora led to subpar performance on standard benchmarks. Training on random collections of internet images really also has consistently led to a significant drop in performance. You can also check that out in this diagram on your screen, which is an overview of the data curation pipeline. Large data pool often shows a long-tailed distribution of concepts. On web-based image repositories, concepts such as websites or dog are much more present than plunger. So that is where these researchers have applied hierarchical k-means to obtain clusters that spread uniformly over the concepts. Data points are then sampled from the clusters to form a curated dataset that has a better balance of concepts. Now, the problem which these researchers are trying to solve here is that the construction and curation of data collections for self-supervised pre-training typically requires extensive human effort, which is costly, time-consuming, and limits the ability to scale the dataset size. This manual process has limitations similar to those encountered in supervised learning. And that is where this new proposed technique of clustering-based automatic curation of high quality data set for self-supervised pre-training is quite significant. The method involves successive and hierarchical applications of k-means, as I mentioned earlier, clustering on a large and diverse data repository to obtain clusters that distribute uniformly among data concepts, followed by a hierarchical balanced sampling step from these clusters. The results are quite good. For example, some of them are shown at the top. So, and these show that features trained on the automatically curated data sets outperform those trained on uncurated data. Also, the performance of features trained on the automatically curated data sets is on par or better than those trained on the manually curated data. There are a lot of things which are happening in this paper, and I will drop the link to it in video's description. But the thing is that this automatic data curation pipeline that produces large, diverse, and balanced training dataset for self-supervised feature learning is quite significant because it involves a successive applications of k-means clustering on raw dataset coupled with resampling clustering steps that improve the distribution of k-means centroids. And this procedure results in clusters that spread more uniformly among concepts. Through extensive experiments, they have also demonstrated the same concept. So this method, in my humble opinion, leads to models that perform significantly better than those trained on raw data for text and satellite images. These results confirm the importance of data curation for self-supervised feature learning and the merit of this approach. Also, applying hierarchical k-means is not really confined to the self-supervised learning context. It can also be considered in place of vanilla k-means in tasks necessitating diverse and representative data sets such as active learning or data pruning. So I will drop the link to this paper in video's description. Let me know what do you think. Always very interested in new and novel data set curation and creation techniques. The code is not still yet out, but I will drop the link to this GitHub repo in video's description. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please do me a favor and share it among your network as it helps a lot. Thanks for watching.